Ever wondered how to detect deadlocks in a distributed system? The answer lies in a clever algorithm known as the Chandy Misra Haas algorithm. This algorithm is a cornerstone in the world of computer science, particularly in the realm of distributed systems. To begin with, it's important to understand what a deadlock is. In simple terms, a deadlock is a state in which each member of a group is waiting for some other member to take action, like releasing a lock or sending a message. In a distributed system, deadlocks can be particularly tricky to resolve due to the absence of a shared memory or a central clock. Enter the Chandy Misra Haas algorithm. This elegant solution was proposed by K. Mani Chandy, Jayadev Misra and Laura M. Haas in 1984. It's an algorithm that provides a way to detect deadlocks in a distributed system using a concept known as OR model. The OR model operates on the basis that a process is only blocked if all the resources it requests are unavailable. Now let's delve into the step-by-step breakdown of the Chandy Misra Haas algorithm. Step 1, the initiation phase. A process that suspects it is deadlocked initiates the algorithm. It creates a wait-for graph, essentially a chart that shows which processes are waiting for which resources. Step 2, the propagation phase. The process starts a probe consisting of a sequence of numbers. This sequence represents the initiator's identifier, the sender's identifier, and the receiver's identifier. The probe travels along the channels in the direction of the edges of the wait-for graph. The third step is the response phase. When a process receives a probe, it checks whether it has already received a probe with the same sequence of numbers. If it has, it means a cycle exists in the wait-for graph, which in turn means there's a deadlock. If it hasn't, it forwards the probe along its outgoing channels. Now, let's recap the key points discussed about the Chandy Misra Haas algorithm. Firstly, this algorithm is a solution to deadlock detection in distributed systems, where traditional methods might fail due to the absence of shared memory or a central clock. Secondly, the algorithm operates on the OR model, which stipulates that a process is only blocked if all the resources it requests are unavailable. Thirdly, the Chandy Misra Haas algorithm consists of 3 main steps: initiation, propagation, and response. The algorithm begins with a process that suspects it is deadlocked, followed by the propagation of a probe along the wait-for graph, and finally the response phase that checks for cycles in the wait-for graph. In essence, the Chandy Misra Haas algorithm is an ingenious method to tackle the complex issue of deadlock detection. Its beauty lies in its simplicity and effectiveness, making it a fundamental tool in the world of distributed computing.